Hello and welcome. For the puzzle I'm about to show you, Cracking the Cryptic's own solution video is titled The Most Extraordinary Sudoku in Years. That video is half an hour long, which is on the short side, so I think it's a fair bet that extraordinary doesn't mean extraordinarily difficult. Let's see. Forcing. Divide the grid into 9 non-overlapping regions, each consisting of 9 orthogonally connected cells. Place the digits 1 to 9 once each in every row, column and region. In each region, place a circle in the leftmost cell of its topmost row. Every circled digit counts how many cells of its own region, including itself, are visible in its column. Region borders block the view. The 9 circled cells together form an extra region, i.e. they are orthogonally connected and contain the digits 1 to 9 once each. It sounds like it's a bit like a jigsaw Sudoku or zig-zag or squiffy Sudoku, whatever you call it. There seem to be a few different names for that type of puzzle, except that the jigsaw pieces aren't given to you, you have to figure them out. Maybe if I actually see the grid, then it'll make a bit more sense. Oh, the grid is completely empty. Interesting. I'd begun to wonder if it's possible for a Sudoku to have no clues whatsoever in the grid itself, such that the rules of the puzzle completely define it, and this seems to be such a puzzle. So this final rule might be the key. The 9 circled cells together form an extra region. So this means there's 1 circle for each possible number of cells in its region visible in its column. And does this mean visible from the circled cell itself? And one of these circled cells will be a 9, and since it's counting cells visible in the column, this will be at the top of one of the grid columns. Whichever one it is, this will be, these 9 cells will be the entire region. And whichever of these is a 1, the cell immediately below it and above it, if there is a cell above it, will be of a different region. As part of the question is how many of these circled cells will be in the top row, and how many will be further down? Ah, I've just thought something. For this region of the circled cells to be orthogonally connected, at least one cell on the second row would need to be immediately below one on the top, in the top row, and that will have to be a 1. Can you see why? If these are both circled, then there can only be one cell in its own region visible in its column. And this furthermore means all the circled cells are in the top 2 rows. And this furthermore means there'll be a number in here and then a number in here. Could be like this, or it could be like this. This will remain to be seen. And the fact that each circle is in the leftmost cell of its topmost row that phrase is reminding me of that line in Shrek about the highest room of the tallest tower. So I'm going off on a tangent there. I can see something else now. This cell has to be the leftmost cell of it, the topmost row of whichever region it's in. Therefore, this is a circled cell. Oops, what did I just do? That's not what I meant to do. I'm sure I saw in here features for drawing lines and circles and such, but I can't seem to see it at the moment. And what number can be in here? I think that it can't be a 1 because that would force this to be circled, and there can't be any more 1s, therefore the rest of them would have to be in here, and that would put 1 here. The 1 region here, which would mean that there's nowhere for the 9 region. if this is a 2, then this is part of a different region. Actually, I can't see that this can be a 2. This isn't circled, so this has to be the next circled cell, which would force this to go here. And then how can this region reach anything? Yes, I need to be careful. If this is a 2 and it's like this, then that would make this the 1, which would make this the circled cell below it, which can't write, so this isn't 2. And think about the 1s now. Where can the 1 be? If it's like this, then this makes this the region of circled cells, and this would force this to be the 9. If the 1 is here, then this is part of another region, and they continue like this. 6, 7, 8, 9. The 9 can't be here, as this would force this to be another 9 region. I can deduce that about this as well. If this is a 9, then that would force this to be a 9 as well. Can this be the 1? It would go off like this, but what it does next would remain to be seen. I've just had another thought. What region could this be part of? Looks like all the cells all these bottom row cells have to be connected to a cell in one of these two rows. No cell can. No. This is the limit of how far the circle cells can go. So that means this cell, I think, has to be part of this region. Which isn't the 9, isn't the 1, as the 1's got to be on the top row to connect to this. This means this isn't a circled cell, so it's not the 1, as the 1 is somewhere along this row, but we've still no real idea of where, and it's not the 9, so it's got to be one of these. Can it be the 8? If it is, then the region would be shaped like this, which would force this region to be the 1. How can I make some progress? If this is 7, then it's like this, which would make this region like this, thereby placing the 1 in a circle here. And giving me another circled cell here, then it would, and this region of circles would be like this. If it's 6, then it's more complicated. This region could go like this, making this the 1 and this the region of circles, or it could be like this, making this a 2. trying to remember how I know that this isn't 1. If it's 1, then it continues like this and the region will be like this. And that will place the... I mean, this region's... Hang on. I'm confusing the actual coloured regions with the regions of circles. Actually, that's a non-issue because every cell in the region of circles is part of a different one of the 9 non-overlapping regions. So if this is a 1, then it forces 9 to be here. Now, what region can this be part of? These are the only possibilities. So the circles, it can only reach up to this diagonal in a region of 9 cells. And only this one is a possible, only these two are possible, possibly circled cells. So if it's here, then no, it can't, it will block this off. This can have no more than 8 cells. Perfect. So this is this region and this is the 9. Now, what does that say for this cell? It can't be part of this region. One, 2, 3, 4, 5, 6, 7, 8, 9. This is the furthest it can reach. So the circled cell of this region is one of these two. This tells us something. At least one of these is circled, and therefore that means this is circled, therefore all these are. Well, colour each one a different colour. One, 2, 3, 4, 5, 6, 7, 8. Now what? That means we... No, this is circled and this is circled, but just don't know which of these two are. If this is, then the one is here, and if this is, then it's the one. And if this is circled, then this is circled, therefore left and above isn't part of the same region, so the one immediately below must be, and I can do that with all of these. And I can continue down a bit because we know this isn't part of the region. Up to here. No, wrong colour. No, it isn't. It's a problem with shades of grey. Once the cursor is over one, it gets confusing to figure out what shade it is. If this is a circle, then this has to extend down here. I think I can deduce something here. If this is circled, then this has these two columns will continue downwards, and this one will as well. Does it get stuck? Let's see. So it's got, that would force this to be an 8 and this to be this one. But that doesn't make sense because these two regions will both now have to be 8, which breaks the rule about the circled cells forming an extra region containing the digits 1 to 9 each. So this can't, so this has got to be the 1, and it extends here. And so this is another region. So we have the shape of the circled cells. They go like this. Now let's see. Let's extend these as we need to. Now what have I here? This has got to be 9. It's, 9 is blocked from this row, and this is the only cell in other cell in the same region. This forms a staircase. I wonder if I can use that to my advantage. Yes, I can shade more of these now. So this is the 8. Seeing 8 cells in its column. So 8 isn't here. And this is the 7. And it continues this way. Thereby, no, this one. One more cell in this region. Not going to assume whether it's here or here at this point. Oh, I can extend all of these to the right. Oh. This is really clever. So we can fill all of these in because we know how many cells in the same column they see. 6, 5, 4, 3, 2. Now can we finish colouring in the regions? That's the big question. Yes, all the regions are coloured in, and we have the numbers in the circle cells. Shame you can't actually see the circles, but you get the idea. This has got to be so from here on it is just Jigsaw Sudoku. This one as the only one that fits on left to fill in this row. And can I fill all the ones in? 1 is blocked from here, so it can only be here. 7 blocked from the rest of this column, so in this region it has to be here. Yes, I have a chain. Now, what can I fill in next? Ah, the 2 in this column maybe can't be any of these because of this 2 here, so it's got to be here. And 2 can't be in here, but it could still be here or here, but either way it blocks 2 from being here, which puts it in one of these. Blocks from here, which puts it in here, these. It looks like I can't do much else, as it could be anywhere in these, in this column. Can I apply the same logic on, same kind of logic on? 3 isn't in any of these. So in this column, it's either here or here. Ah, look at this 9. This sees all these cells, leaving only this one in the blue region to be a 9. I think I can do the same as I did with the ones. Yes, 9 here, 4, 9's not here or anywhere in here, so it's here, and so on. And this gives us the 2's, I think. 2. Yes. 2, 2, 2, 2, 2, 2. And 3 is 3. Not in here, so 3. 3, 3, 3, 3. But I can't draw any conclusion about... Oh yes, I can, because I've still got a 2 to fill in here, so this is the 3 in here, and that leaves this cell for the 3 in this region, and here for this one. Four, same logic, not in here, therefore in this region it's here, and we can continue. 4 only fits here in this one. In this one only fits here, and this one only fits here. 5. 6. 7. 8. Not forget to fill them in this yellow region. So I've done it 37 minutes 16, which isn't that much longer than Cracking the Cryptic's own video. So it looks like this puzzle was daunting at first, but I managed it. Thank you for watching.